Hello, this is going to be the 2024 District's Number Sense Guide. I'm going to go through all the tests, hope to answer the questions, and this is going to actually be the last 2024 video I did. I figured I'd end it off on a bit of an easier test to go through. Let's begin. Here we go. Starting at number 1, you have a bunch of numbers added together, 322 plus 327 plus 2024. Just add up all the digits at a time. Add up the ones place, you get 13, carry a 1, write a 3. 2 plus 2 plus 2 plus that 1 you carried over is 7. 3 plus 3 plus 0 is 6, and 2 is equal to 2. Number 2, 3 and 2/7 minus 2 and 2/3. You should hopefully realize that 2/3 is greater than 2/7, so this fraction is going to have this subtraction is going to get rid of one of these extra ones place, 3 minus 1 minus 1. So there's going to be no whole number, and it's just going to be a fraction, basically. So if you expand this to have the same denominator, you multiply this by 3 to get a 6 over 21, and this by 7 to get the 14 over 21. So now you have 1 and 6 over 21 minus 14 over 21, and then you just do that. 27 minus 14 is 13, and 13 over 21 is your answer. 5.6 times 7 plus 8. So 5.6 times 15, which is going to be the multiplied by 15 trick. 5.6 times 10 plus 5.6 times 10 over 2. So 56 plus 56 over 2 is equal to 84. Number 4, 5 over 8 divided by 4 over 5. When you're dividing by a fraction, you can flip and multiply. So flip the fraction, multiply the numbers, and you get 25 over 32. 5. This is 31 squared is equivalent to 30 plus 1 squared, which if you distribute, you get 30 squared plus 30 plus 30 plus 1, and you'll get a value of 961. Number 6, improper fraction. What is this number? Let's ignore the whole number right now and figure out what fraction the decimal would be. You should hopefully recognize this fraction to be equivalent to 7 over 12. You can tell partly because it's repeating 3's, and then it's slightly less greater than 0.5. So yeah, it's 7 over 12. And now you have to add in your 3. So convert to an improper fraction, multiply your 3 by your denominator to get 36, add it to your numerator, and you get 43. So your answer is 43 over 12. Number 7, the least common multiple of 98 and 56 is what? Well, least common multiple is equal to the two numbers multiplied by each other divided by the greatest common factor. So if you're looking through greatest common factors, you should hopefully be able to see that it's 14. You'll realize that this is 14 times 7, this is 14 times 4. If you don't, you can use a Euler's method where you subtract them over and over again, or you take the remainder of each one subtracted by each other over and over again. 98 minus 56 is 48. 56 minus 48 is 8. Hold on. Honestly, it's been a while since I've done that. You can generally just see it. And then once you have your GCF, take the two numbers, multiply it, divide it by your GCF. So 56 divided by 14 is 4. 98 times 4 is 392. So number 8, 4/5 is equal to what percent? Well, to convert to a percentage, you multiply the numerator by 100. 400 over 5 is 80%. Number 9, remainder when a number is divided by 9, you add up all the digits and then take the remainder when that is divided by 9. So if you add all these things up, you get 19. 19 divided by 9 has a remainder of 1. Number 10, 2024 minus 327 times 22. Well, that's pretty close to 1700 times 22, which is 1700 times 2 times 11, which is 3400 times 11, and then you can use your 11's trick to figure out something very, very close to the real answer. Number 11, if CDs cost $4.75 and 3-pack costs $12.95, how much is saved by buying a 3-pack? Well, how much does 3 CDs cost buying them individually? 4.75 times 3 is equal to 14.25. If that's a little hard to do, you can do 5 times 3 minus 0.25 times 3. So 15 minus 75 cents. And you'll get 14.25. Then you subtract 12.95. Again, if that's a little difficult, add 0.05 to both of these, so you get 14.3 minus 13, and you get a value of 1.3. Number 12, cube root of 2,744. This should be a well-known answer for 14's cubed. That's just a cube you should know. Number 13, 8% tax on $322 is what? Well, 0.08 times 322. So just use your normal multiplication. So 8 times 2 is 16. 6, carry the 1. 8 times 2 is 16. Add that extra 1, you get 17. Carry another 1. 8 times 3, 24, plus 1 is equal to 25. And then just put the decimal, once you have all those numbers written down, put a decimal where it would be appropriate. As you can see, that it would make it easily the most sense to have your decimal here, because you can imagine 8% of $322 is around 25 bucks, not like 250 bucks and not 2.5 bucks. Number 14, 3 divided by negative 5 times 2 minus 1, essentially. So you just have negative 6 over 5, and then you have your minus 1 there. And it's very simple. Just do the math, and you get negative 2 and 1/5. Number 15, 12.5% of 96 is what? Well, 12.5% is equivalent to 1/8. That's the fraction you should know. So 96 times 1/8 is equal to 96 divided by 8, which is equal to 12. And then 16, 5/8 of 96. Well, the 5/8 is 5 times 1/8. So multiply the previous answer by 5, and you get 60. Number 17, 0.75 times 96 is what? Well, in this case, 5/8 plus 1/8 is equal to 6/8, which is the equivalent of 0.75. So it's just the previous two answers added together. Number 18, there are how many positive integral factors of 36? We'll put 36 in terms of its primes. So 36 is equal to 2 power to 2 times 3 power to 2. Once you have these exponents here, add 1 to each of them and multiply them. So 2 plus 1 is equal to 3 times 2 plus 1, which is 3. So 3 times 3 is a 9. 19, 33 and 1/3 of 20% of 15 is what? Well, what is 20% of 15? You have to, 20% is 1/5. So 15 divided by 5 is 3. And then 33 and 1/3% is 1/3. So divide that by 3 again, and you get 1. Number 20, 300 times square root of 2 plus square root of 7. You should know approximately what these are. Square root of 2 is 1.414, and square root of 7, I'm fairly confident, is 2.649. I don't actually know that for sure the last term because I memorized it to just be 0.5. And then once you have that, you just add them together. You get a value that's slightly greater than 4. So a little more than 300 times 4. 1220, which should easily work. 21, find digit b greater than 0 such that this minus that is equal to 405. Well, you only really need to look at the ones place. What number, 2 minus what number will get you 5? Well, the answer would be negative 3. But which isn't possible. So imagine it where you have to take a 1 from the tens place to completely subtract it. So now you have 12 minus what number is equal to 5, and that number is clearly 7. 22, if 29 over 33 is equal to AB, what is A plus B? Well, this is a clearly defined a sequence where a number is divided by 99. So 29 over 33 is equal to multiplying both of those numbers by 3, 87 over 99, which is the equivalent of 0.878787. So 8 plus 7 is 15. 23, write 32 and 2/5 million, 2,024 in digit. 32 million, 2/5 million, there's your 400,000. 2,000 right there, and then you have your 24. 24, 3 plus 22 times 3 minus 27 divided by 4 has a remainder of what? Take the remainders whenever you can. 3 plus 2 times 3 minus 3. So then you have that. You have 3 plus 6, or 3 plus 2, minus 3. So 3 minus 3 plus 2 is 2. So 25, 8 and 3/7 times 8 and 4/7 is what? Well, these whole numbers are the same, and these fractions add up to 1, so we can use that special trick. Your whole number is going to be 8 times 9, or 8 times 8 plus 1 is equal to 72. And then your fraction is just going to be the two fractions multiplied by each other to get 12 over 49. 26. Tri, union, quad, intersections of bi and pent contain how many distinct elements? So unions are combining all the elements in your list, and intersection is how many elements are in both lists. So, in other words, how many elements in triquad are also in bipent. So T is in there, R is not, I is in there, as you can see right here, by, Q is not, U is not, A is not, and D is not. So there are two distinct elements in the intersection. So, okay, 27, 322, base 7 is what in base 10? Base 7, 7 power to 0, 7 power to 1, 7 power to 2. 3 times 7 power to 2 is 3 times 49 is 147. Add that to 2 times 7 is equal to 14, get 161. And then add that to your 2 to get 163 base 10. 28, if 1/7 plus 1 over x is equal to 1 over 3, then what is x? Put all this over the same numerator. So 3 over 21 plus 1 over x is equal to 7 over 21. So x power to negative 1, which would move this x on the top, has to be equal to 4 over 21, because 3 plus 4 will get you that 7. So 4 over 21 power to negative 1, flip that number, and you get 21 over 4. 29.727272. This is your divide by 99 thing. 72 divided by 99. Simplify that by dividing both of them by 9, and you get 8 over 11. 30. Look for all your groups. Here's a group of 2. Here's a group of 2. Here's a group of 2. And there's a group of 1. So there are 4 groups and 4 digits. So look for this 3 combined with these previous 2's. So 322 is very close to 18 squared, which is 324. That means your first digits you're going to write are 18, and then you can fill in the rest with zeros. So, excuse me, yeah. So yeah, 1800. So you have your 4 digits. 31, 5993 times 7 plus 49. This is the equivalent of 6,000 minus 7 times 7 plus 7 times 7. Which cancel out these two things, and you're just left with 6,000 times 7. Okay, 32, if f of x is equal to 4x squared plus 20x plus 25, f of 15 is what? If you're bringing in these factors in, you get 2x plus 5 squared. As you can see, square root of 4 is 2, square root of 25 is 5. And then it would make sense to add 25, or add 5 instead of subtracting, because this coefficient is positive. So 2x plus 5 squared, 35 squared. Use your squares ending in 5 tricks. 3 times 3 plus 1 is 12. And then you just always write 25 at the end. 33, multiplicative inverse of 0.24. Well, 0.24 is 24 over 100. Divide both sides by 4, you get 6 over 25. Take the inverse of that, flip your numbers, and you get 25 over 6. 34. This is a very annoying series. You can see that each number doesn't really seem to relate much with the next one. It relates more with the one 2 before. So hopefully you can recognize that this is kind of a split series. Here's a 2, here's a 3, here's a 5, here's a 7. This is a series of primes. So this number right here would be 11. And then you have your second thing, 0, 2, 4, 6, 8. These are even numbers. 6 times 11 is 66. 35, 202 base 10 is what in base 4? Well, the highest 4 power to a number that can go into 202. 4 power to 3 is 64. And 4 power to 4 is 256, which is too much. So 4 power to 3 is 64. 202 can go into 64 3 times. Write a 3. Subtract 192, or 64 times 3, and you get 10 left over. 10 cannot go into 4 squared, but it can go into 4 power to 1 2 times. Leave you with 2 to write right here. And you get 3022 base 4. 36, cost of 15 pints at 32 cents each. Well, 15 times 0.32, so is equivalent to 0.32 times 10 plus 0.32 times 10 divided by 2. And you get 3.2 plus 1.6 is equal to $4.8. 37, the cost of 17 pints at 32 cents each is what? Well, this is equivalent to 2 more pints than the previous one at the same cost. So add 0.32 times 2 is equal to 0.64, and you get 5.44. 38, cost of 8.5 pints at 32 cents. Well, that's half the number of pints as the previous one, so divide the cost by 2. And you get 2.72. 39, let x plus 11 over x minus 8, and then the same thing but reverse. This is your kind of difference in I don't even know what the trick is called, but it's like an old Brian Heath booklet. But what you need to know is look for the distance between 11 and -8. So 11 minus -8, you get 19, and square that value, and that is equivalent to your b. 40, cube root of this giant number right here. Since you're looking for cube roots, look for groups of 3, 0, 2, 4, 272, and 322. So now you know that you have 3 groups, you have 3 digits. Look at the first 2 groups. 324 is about 7 power to 3. It's a little less than that. Technically, you don't really need to look at this group because this number is so high. So it's a little less than 7 power to 3. So write 6, 9, and then add your extra 0 to compensate for the 3 digits. 41, 309 squared. Well, it's a square of a number with a 0 in the middle, so 9 squared will get you 81. That'll be your last 2 terms. 3 times 9 times 2 combination 1, which is just 2, will get you your middle term, so 3 times 9 times 2, which is 54. And then you have 3 squared is equal to 9. Did something happen? All right, it must have been my imagination. Anyway, let's continue. 42, positive geometric mean of 4 and 16 is what? The geometric mean of two numbers is the nth root of all n numbers multiplied. So there are two numbers here. So the second root, or the square root of 4 times 16, so the square root of 64 is 8. 43, the simple interest on $422 at 7% for 2 years is what? This is probably the most difficult or computing intensive problem on the test. You need to do 322 times 7 times 2, or 322 times 14. It is a very difficult FOIL problem, and then you just have to figure out that the decimal would clearly make the most sense right here. It's not $450, it's not $4.5, it's 45 bucks. So yeah, just a very difficult FOIL to do. 44. The arithmetic mean of 22, 27, and 24 is what? Well, the arithmetic mean is all the numbers added together divided by the total number of numbers. So 22 plus 27 plus 24 is 73. There are three numbers, to divide that by 3. And it's not even divisible by 3, because as you can see, these digits add up to 10, which is not divisible by 3. That's that's how you check whether it's divisible by 3, and since it's not, you don't have to simplify at all. So just write that as your answer choice. 45, 54 squared plus 66 squared. There are two different ways you can do this. You can recognize that this is the complicated, if you move these around, this ones place is 1 greater than this tens place, and what was it, like the ones places add up to 10. And then if you do that and whatnot, you will see, or maybe it was this ones place and that tens place. I would easily recognize it if it was on the problem. I'm sorry. But in any case, it doesn't really matter. Just know that the trick works. This is a number in front. So 6 squared plus 6 squared is 72. 72 times 101, 72, 72. You can also do it the way I showed down here, where you're doing 60 minus 6 squared plus 60 plus 6 squared. This is going to cancel out a few of the terms, and you're just going to be left with 60 squared times 2 plus 6 squared times 2. And then 46, 2 power to 5 plus 7 power to 5 minus 2 divided by 9 has a remainder of what? Well, this 2 and 7 are going to cancel because they're the same distance from 0 and 9 respectively, and they're being powered to an odd number. Now you just have 0 minus 2 is equal to 9 minus 2 is equal to 7. 47, if 4x minus 3y squared is a stuff, b stuff, and c stuff, what is a plus b minus c? So first off, we'll do the easier part, which is figuring out what a plus b plus c is, which just happens when you replace everything with 1, because that would get rid of all this x squared and xy and then y squared and etc. So replacing all that with 1, you get a plus b plus c is equal to 1 squared, which is 1. So now you need to subtract that. Well, a plus b minus c is equal to a plus b plus c minus 2c. So you just need to figure out what c is. Well, c is the y squared coefficient. Negative 3 squared is 9. So 1 minus 2 times 9 is negative 17. 48, the product of the roots of this thing right here is what? Product of the roots is the constant divided by the first coefficient. So if you move this over, you get negative 7 over 3. And then since this is x squared, it's an even power, you do not flip the sign. Okay, 49. Adding all the stuff in base 8. Again, you don't even have to worry about what base it is. Just do 7 plus 2 minus 4 is 5. 2 plus 2 minus 2 is 2. And then 3 plus 3 is 6. Not hard at all. 50, 323 million, yada, 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 divided by 322. Well, 327 divided by 322 is close to, 1. So just write down a 1. And then you got to figure out how many digits are left. Well, there are 3 digits being used here, 3 digits being used here. So you have 4 left over and 0 left over. So 4 minus 0 is 4, which means you have 4 zeros you need to write after the problem. So yeah, 4 unused digits minus 0 unused digits. 51. The 11th term of 1, 1, 2, 3, 5, 8 is 89, was the 12th term. This is a very easy to see Fibonacci series. If you remember the Fibonacci series, you'll remember that the term before 89 is 55, and the term after 89 is 144. Alternatively, if you like pain and suffering, you can just map it out yourself. 5 plus 8 is 13, 13 plus 8 is 21, 21 plus 13 is 34, 34 plus 21 is 55, and 55 plus 89 is 144. 52, this is going to be your your difference in cubes divided by your, well, I guess, difference in numbers. This is going to be the trick we've seen on this problem before. You may think it's weird because you're subtracting the bigger number now, but since you're also doing it this other side, the negatives are going to cancel out. So it's the same thing as if these numbers were swapped. So as a result, add the two numbers together. 11 plus 13 squared is 576, and then subtract them from the two numbers multiplied. So 11 times 13 is 143. 576 minus 143 is equal to 433. 1 over 28 plus 1 over 70 plus 1 over 130. Whenever you're given problems like this, you should usually look at what the denominators are made of. So 1 over 4 times 7, which would be what you're being multiplied to get there. Then you're also adding 1 over 7 times 10, and then 1 over 10 times 13. So since these numbers are all adding a constant 3 to get to the next one, you can use a special trick with fractions, one I can't prove, where you basically add up all the numerator, or add up this 1 3 times to get 3, and then you divide it by the first multiplied number, and you divide it by the first number multiplied number, and you divide it by the last multiplied number. So 3 over 4 over 13. 54, 25 plus 10 plus 4 plus 1.6. This is a very clear geometric series. Each number is 2/5 times the previous one. So now you use your formula for sum of geometric series. 25 over 1 minus 2/5. This one is a constant. So now you have 25 divided by 3 over 5. Since you're dividing by a fraction, you can flip it, and you get 25 times 5 over 3, which you don't have to simplify. Just write 125 over 3. 55, if square root of 12 plus square root of 8 plus square root of x minus 8 is 4, then what is x? Well, to get a square root to be equal to 4, it has to have 16 inside. There's 12 here, so you need this square root to yield 4. Here's an 8. For this square root to yield 4, you need 16 inside. There's 8. You need 8 more. For this square root to yield 8, you need to have 64 inside. So x minus 8 is equal to 64. And then once you do that, 64 plus 8 is 72. 56, two dice are rolled. Find the odds that the sum of the number is less than 4. Well, there are two, based on how dice work, there is one chance for them to roll a sum of 2, two chances for them to roll a sum of 3, three chances for them to roll a sum of 4, and so on until you get to 7 where it reverses. So 1 plus 2 is equal to 3. So there are 3 chances out of the 6 power to 2 is equal to 36 possible combinations. So you'd have 1 over 12. But now since you're looking for odds, odds are chance of success over chance of failure, and probability, which we solve for, is chance of success over total chance. So to get your denominator, you have to subtract this 1 in the numerator over here. So 1 over 12 minus 1 over 12. Or sorry, no, that's not what I meant. Just subtract 1 from this denominator of 12 to get 1 over 11, basically. And that's the difference between odds and probability. 57, let 3, 2 over m times n and 2 over 23 is equal to 20. M and n are natural numbers. Find n minus m. Well, as you can see, 3 times around 6 will get you that 20 you're looking for when you're adding a few extra stuff. So now you have this number here, 6. Convert to an improper fraction. 6 times 23 is 138, plus 2 is 140. 20 divided by 140 settles to 1 over 7. So now that you have 1 over 7, you know your denominator is going to be 7, and you get a value of 7 for your m. 58, 2024 base 6 divided by 3 base 6 has a remainder of what? Well, since this is 6 powered to 1, 6 powered to 1 divided by 3 has a remainder of 0. So anything that's being multiplied by 6 is going to have a remainder of 0 when divided by 3. So the only term that we care about is the first term right here, which is 1, or 4 divided by 3 has a remainder of 1. 59, Let 4 power to 5 times 8 power to 3 divided by 128 equal 2 power to k. What is k? Well, put all these in terms of 2 power to a number. Take the square root of 4 to get 2. Multiply this 5 by 2 to get 2 power to 10. Take the cube root of this 8. Multiply this 3 by that 3 you just rooted. You get 2 power to 10 times 2 power to 9. And then 128 should be known to be 2 power to 7. Add and subtract all the exponents, and you get a value of 12 for k. 60, 125 power to 2 divided by 25 power to 3 times 5 power to 5 is what? Again, put all these in terms of 5 power to a number. 125, cube root of that is 5. 5 power to 2 times 3, or 5 power to 6. Similar process for here, 5 power to 6 as well. That's equal to 1. And then you're just left with 5 power to 5. So in other words, this entire problem is just asking, what is 5 power to 5? And if that's a little hard to do 5 squared to get 25. 25 squared is 625, and that accounts for 4 of your 5. So multiply that by 5 to get everything. 61, sine of 17 pi over 6. Sine resets after 2 pi. Subtract 2 pi from that. You get sine of 5 pi over 6, which you should know to be 1/2. 62, if 22 root 3 times 27 root 3 is what? Here is k mod n. And then what is k? Well, when you're multiplying exponents like this, that means that you're basically adding them. So in other words, what is 22 over 3 plus 27 over 3? Well, it's 49 over 3. K is equal to 49. So once you do that, 63. The fifth hexagonal number is what? Well, hexagonal numbers means your hexagonal is 6. Multiply your 5 as your number times 6 minus 2, which is 4. And subtract that by 6 minus 4, which is 2. That's your number times type of number. You do that, you get 18. Multiply it by your number, 5, and divide it by 2. So you get 18, 5 times 18 over 2, or 5 times 9 is 45. 64, if f of x is equal to this giant thing, what is f of negative 1 of 5? Replace this y with 5 and solve for this x. So 5, add this 4, you get 9 is equal to this fraction right here. Multiply it by your denominator, you get 18 minus 27x is equal to x plus 1. Move over the x, move over this 1, and you get x is equal to 17 over 28. 65, if x is 7, y is negative 6. What is this giant thing right here? Hopefully you should recognize this to be the equation for difference or for sum of cubes. So in that case, 7 power to 3 plus negative 6 power to 3, 343 plus negative 216, 127. Number 66, second pentagonal number minus the fourth pentagonal number. Well, pentagonal numbers, similar process but before. Type of number, 2 times pentagonal is 5. 5 minus 2 is 3. 2 times 3 is 6. That's subtracted by 5 minus 4, which is 1. Now you have 5 times 2 over 2, which is 5. Then you do the same thing for the fourth number. Replace all the 2's with 4's. You get 22. And you get 5 minus 22 is negative 17. 67. If h of x is x squared minus 3, g of x is x minus 1, h of g of 0, well, g of 0 is clearly negative 1, and h of negative 1 is 1 minus 3 is negative 2. 68. Change 12 over 25 to a base 5 decimal. Well, the first decimal is equivalent to 1 over 5 times your number, and the second one is 1 over 5 squared times your number. Similar to base 10, where in base 10 it would be 1 over 10, 1 over 100. In other words, 12 over 25, well, that's equivalent to 2 over 5 plus 2 over 25. If you expand this out to be 10 over 25, then you write 0.22 to represent this number to be this 2, and that 2 to be the second 2. 69, this is your annoying remainder problem with an exponent half of the prime you're dividing by. First off, the easy part, let's simplify this a bit. 24 power to 9, 24 divided by 17 has a remainder 7. It's equal to the remainder when 7 is powered to 9. So note that 7 is not square rootable, and if you take the other side, 10 is not square rootable either. So that means you have to go in and see if you can find a perfect square when you're adding 17 to figure out a remainder. So 24 is not, 41 is not, 58 is not, 75 is not, 92 is not. And then you don't need to go past half of this number squared, so you don't need to go any further. Then once you have that, you note that since there's no square root, you know that based on that logic, this number powered to 17 over 2 minus 0.5, or 8, would be equal to 17 minus 1 and not 1. So 17 minus 1 is 16. 16 times 7. Well, 16 times 7, that's the equivalent of negative 1 times 7, which is negative 7. And then you add your 17 to that to counteract it, because 17 divided by 7 has a remainder of 0, so you can add it without any issue, and you get a value of 10. Number 70, rocket is traveling at 5,280 miles per hour. How many feet per second? Miles per hour to feet per second, divide by 15, multiply by 22, or multiply by approximately 1.5, which you should see to be close to 8,000. It's probably a little over, but not enough to be out of range. I imagine it's probably a little closer to 700-800 or something. Then once you have that, 71, find k, 0 less than or equal to x, less than or equal to 22. If all this stuff divided by 22 has a remainder of k. Well, 11 power to 4, that's a bit hard to do, so let's take it in terms of steps. 11 power to 2 is 121, divided by 22 has a remainder of 11 again, because you can do 121 minus 22 times 5, which leaves 11 left over. So 11 squared, we literally just did that. The remainder is 11. And then you plus 2 power to 6, which is 64, divided by 22, the remainder of that, which is going to be 20. Then you just have 11 plus 20, which is equal to 11 minus 2, which is equal to 9. 72, let h of x is equal to 3x squared plus 2x plus 1. Find h prime of negative 4. Well, to figure out that, you have to take the derivative of your function. So power rule, decrease the power by 1, multiply it by your original power, you get 6x. Reduce the power by 1, multiply it by your original power of x powered to 1. So then you get 6x plus 2. Then once you have that, plug in negative 4, and you get a value of negative 22. 33, 2 and 2/3 fathoms is how many inches? Fathoms convert to feet, multiply by 6. So you get, first off, turn this into an improper fraction. 2 times 3 plus 2 is 8. 8 over 3 times 6 is equal to 8 times 2 is equal to 16. Then you multiply it by 12 to convert to feet to inches. 12 times 16, if that's a little difficult. It's the same distance. There's 2 away from 14 squared, which is 196. So 196 minus 4 is 192. 74, let AB be an inflection point for this equation. Inflection points are when the double derivative is equal to 0. The first derivative is going to be 6x squared minus 3. So the second derivative is going to be 12x. Then once you have that, when is that equal to 0? Well, it's 0 at x equals 0. So plug in 0 to your equation, and you get a value of 5. So your point is 0, 5. So 5x squared plus y squared is equal to 4y has an area of what? Well, you got to move this 4y over and then put it back into the equation. So x squared plus y minus 2 squared. That'll put, if you distribute this out, you'll see that you get the minus 4y you would get normally if you move this over here. And then by doing that, you're adding negative 2 squared to the equation if you distribute out again. So you have to compensate by putting a negative 2 squared equals 4 on the right side. And then you'll see the area of your circle. This represents r squared, so the area is going to be r squared times pi, or 4 pi. So the sixth integral of a linear function. Well, the integral of a linear function, there's an easy trick for that. Take the average of your values. So the average of 2 and negative 1 is 0.5. Plug in that for x. You get negative 2.5. And then you multiply that by the distance between your bounds, or 3. So negative 2.5 times 3 is negative 7.5. 37, domain of f of x is equal to that, of this is equal to that, where it has to be real. What is w plus y? Basically, you're just figuring out when do either of these square roots have a negative inside them, which would make your answer non-real. So, figure out when that happens. We need to figure out when each of these equations are equal to 0. Because if they go any farther than 0, they'll be negative. So it's clearly going to happen at 5 over 3 and 7 over 2. So 5 over 3 plus 7 over 2, put them under the same number, 10 over 6 plus 21 over 6, and you get 31 over 6. So V8, this is a bit of a difficult series to find. You'll see that this is 8, 12, 20, 28. You'll notice that there's some weird times 4 shenanigans going on. So if you look closely, you'll see that this is each prime times 4. So 2 times 4, 3 times 4, 5 times 4, 7 times 4, 13 times 4. So, and this is going to be 11 times 4. So V9, this is just, okay, I guess I did say, what was it? This problem was probably the most difficult computing intensive problem. I still agree with that because you don't see the 14 while you're doing it. So you got to keep on that extra bit of information. But this is a very, very close second. There are a lot of different ways you can do this. You could try to do a 22 times 27 way, and then you add on the extra 3 times 22 plus 3 times 27. You could try that, or you can just do the painful FOIL. That I'm not going to go through. Either way, if you do that, you'll get this giant conglomerate right here. So number 80, back to an easier problem. It's an approximation one. Move this down a bit, move this up a bit, so you get 300 times 600. It's probably a little more, but 1800 is still easily in range. So it doesn't matter. So yeah, move this down 22, move this up 30. This is probably like a removal of like 8% and an additive of 8%, somewhere around there. So yeah, just multiply them together, you get 180,000, and you are done with your test. All right, that was the entire guide. I hope you enjoyed. If you have any questions, leave a comment or ask me in person. Or if you want any more in-depth explanations or proofs, I'll try to give you to them if you want them when I have more time to go over them with the amount of dedication they need. See you guys later.